Step 0, factor this first completely. The bottom does factor as the difference of squares. X plus 5, x minus 5. Now that we have it completely factored, do we have any non-permissible values? X can't equal 5 and x can't equal negative 5. Nothing simplified. When nothing simplifies, your non-permissible values will always be vertical asymptotes. One of them will be at x equals 5, the other vertical asymptote at x equals negative 5. Step 2, we're going to look, does this one have a horizontal asymptote or an oblique asymptote? So if we look at the highest power in this entire rational function, it's an x squared. We have negative 2x squared in our numerator, and we have 1x squared in our denominator. If we simplify that, we get y equals negative 2, and that will be a horizontal asymptote. So if the degrees are the same, whatever the leading coefficient of those highest degree values are will be what your horizontal asymptote will become. Step 3 was finding all of your intercepts. Your y-intercept is easily found by plugging in 0 into your original equation. If I go back up and I plug in 0 into my original equation, can you see that you're going to get 0 over negative 25? So our y-intercept is going to be at 0. Our x-intercept, or x-intercepts, there might be more than one. Our x-intercept is when your numerator is going to be 0, because you plug in 0 for y. So if I look, what is the only thing that's going to make our numerator equal to 0? 0. So now when we look at graphing this, step 4, drawing the graph, we add all of our asymptotes. So we have asymptotes at negative 5 and 5. And we have an asymptote at y equals negative 2. We know one point because our x-intercept and y-intercept was the same. So to figure out some more values and what's going to happen with this graph, we're going to need to find some more points. What always happens is our domain is broken up into sections according to our vertical asymptotes. So we have 2 vertical asymptotes. We have 3 sections to this graph. The section before x is equal to negative 5, the section between negative 5 and 5, and the section when x is bigger than 5. Here we need to find out some other points. So I'm going to say, well, what happens if I plug in negative 6? So I'm going to go up to my equation here, perhaps the factored one. If I plug in negative 6, can you see that negative 6 squared would be 36 times negative 2? I'd get negative 72 on top. And if I plug in negative 6 into the bottom, I'm going to get a negative 1 there and a negative 11 there. So it's going to be negative 72 over 11. What would that be as approximately as a decimal? 6 point something between 6 and 7. So I need to have a point on my graph, -6, comma, 72 over 11. So, or sorry, it was negative 72 over 11, correct? There we go. -6, negative 72 over 11. Now, since I have that point in that section, I now know that it is going to approach the asymptote this way, because that's what our asymptote does. That's horizontally. It tells us where our graph is going to go when x gets really large, both positive numbers and really large negative numbers. We don't really exactly, because there is a possibility it could do that. But we're going to, this is all that they're going to expect you to do for this. Okay? We're going to find out what happens on the other side, so that's a good thing. Let's plug in 6. Can you see that when you plug in 6, you'll still get negative 72 on the top, and plugging in 6 here would give me 11 and 1, and so we get the exact same point on the other side. So we get positive 6 and negative 72 over 11 on this side as well. Now what happens in the middle is a little bit of a mystery, because in the middle your graph could possibly go through your asymptote. So when we're trying to graph our middle section here, we again are going to need a few more points. So I'm going to say, well, what happens as I get close to the asymptote? And a nice point, a nice whole number closest to the asymptote would be 4, or on this side, -4. And so when I plug those values in, let's start with the -4. If I plug in -4, I'm going to get -32 in my numerator, and -4, this would be 1, and this would be -9. -32 over -9, which is 3 point something. Same thing on the other side. If I plug in 4, on the top it's still going to be -32. When I plug in 4 on the bottom, I'm going to get 9 and 1. Nope, -1. So I get -32 over -9 again. -32 over -9. And so because of those points, I know that my graph is going up. Notice our graph bounced off our x-intercepts here. If we look, can you sort of see in the numerator that your x-intercept has a multiplicity of 2? So it's sort of connected. Some of these ideas are connecting from our previous units. And so to recap the things that we did, we always find non-permissible values to find our vertical asymptotes. Number 2, find out if you have a horizontal asymptote or an oblique asymptote. Find your intercepts and as many points as you need to graph your graph. So we started with our intercepts. We noticed that we needed some more points in the other sections. We plugged those in with the table of values to figure out -6, -72 over 11. And the points aren't going to be necessarily nice because you are dealing with fractions. So you're going to have to estimate a little bit of where those values are going to be. And once you've got enough points, then you can draw your graphs near your asymptotes. Okay, question for this one is number 4. Again, the last one was number 3. This one's number 4. Next one's going to be number